All right, in this lesson, we are going to solve quadratic equations by factoring. Okay, and so in order to do this, it involves something called the zero product property. And the zero product property says that for any real numbers, a and b, if their product equals 0, that means either A equals 0 or B equals 0. The only way for two things to multiply together and give you 0 is if one of those individual factors were 0. Okay, and so in order to set up a zero product property situation, we need to get our quadratic on one side of the equal sign. So I am going to subtract the 5x from both sides. And that gives me 6x squared minus 3x equals 0. You want it equal to 0, just like for quadratic formula. Only now we are going to factor this quadratic. And so because there's no constant term, this is a GCF situation. Both of them have an x and both of them have a 3. So 3x is our GCF. And then when I factor that out, that leaves me with a 2x minus 1. Okay, and so these are my factors. A times B is equaling to 0. So that means either A was 0 or B was 0. In this case, A is 3x. In the other case, B is 2x minus 1. Okay, so we just set both factors equal to 0 and then solve the two linear equations. So we factor quadratics into two linear equations and set each one equal to 0. Okay, and so divide the first one by 3, we get x equals 0. That's one of our solutions. Over here, we have to add 1 first and then divide by 2. So x equals 1/2. Okay, so our solutions are 0 and 1/2. Okay, over here, we need to get the 7x on the other side. He goes in the middle. Always write ax squared plus bx plus c, so descending order for the x's. Okay, and so to factor this, I need two numbers that multiply to my constant term 12, but add to the middle number 7. That's 3 and 4. Since a is 1, I know my factors are x plus 3 and x plus 4. And so using the zero product property, either x plus 3 is 0 or x plus 4 is 0. On the left side, x would equal -3. On the right side, x would equal -4. Okay, and so -3 and -4 are our solutions. Okay, over here, we need to move the 3 to the other side. And this time, A is not 1, and we don't have a GCF situation. So this one we have to factor by grouping. Okay, we still need to find two numbers that multiply to A times C. A times C is -18, but add to the middle number 7. And so that would be 9 and 2, and make the 2 negative. Okay, and so we split our middle term into 9x and -2x. Bring down your -3, bring down your 6x squared. Okay, and now factor 2 at a time. Out of the first pair, I can get a 3 and an x. And so that leaves 2x plus 3. Out of the second pair, since this term is negative, my GCF is negative, and we can't get anything else. And so -1, when you can't get any other number, it's automatically a 1. So when I divide by -1, I get 2x plus 3. The parentheses match, and so when that's the case, you know you've done everything right. The parentheses is one of your factors, 2x plus 3. The other factor comes from what is in front of the parentheses, the 3x minus 1, same order. Okay, and so remember, all this was equal to 0. So by the zero product property, either 2x plus 3 is 0 or 3x minus 1 equals 0. Subtract 3, divide by 2. We get x equals negative 3 halves. Add 1, divide by 3. We get x equals 1/3. Okay, and so my solutions are 1/3 and negative 3 halves. Okay, over here, we need to move both of these to the positive x squared side. Always make sure your x squared term is positive. And this time, a isn't 1, but it is a GCF. I can divide every single one of these numbers by 2. And essentially, you can think of it as dividing the entire equation by 2 right off the bat. Because there's an equal sign, you don't have to keep that 2. If there's a variable with your GCF, like for number 1, do not divide by a variable. But if it's just a number, you can cancel it and get rid of it and ignore it. Okay, and so now when we factor, we're looking for two numbers that multiply to 2 but add to negative 3. Negative 1 and negative 2. And so either x minus 1 is 0 or x minus 2 is 0 by the zero product property. So x equals 1, x equals 2. Okay, on this next one, it's not arranged very well at all. We want x squared to be positive, so I'm going to move both of these to the other side. So minus 2x and then positive x squared. So x squared plus 16x plus 64 equals 0. And so we need two numbers that multiply to 64 but add to 16. That's 8 and 8. Those match, which means this was a perfect square trinomial. And so whenever you have a repeated factor, you don't have to set them both equal to 0. It's going to be the same answer. You're only going to have one solution, x equals negative 8. Okay, for this last one, we need to move the 9x. And then this is another GCF situation. We have an x involved in both, and we also have a 9 involved in both. So 9x can be factored out, leaving me with a 9x minus 1. And so one factor is 9x, the other factor is 9x minus 1. In this case, x equals 0. In the other case, we get 9x equals 1, which means x equals 1/9. Anytime you have a GCF of x, that means 0 is going to be one of your solutions. Okay, this last one is a application problem. The height of a javelin in feet can be modeled by the function h of x equals this, where x represents the number of seconds after the javelin is thrown. After how many seconds will the javelin hit the ground? Okay, and so for picturing this, it's going to be an upside down quadratic, and it's going to hit the ground at some point. Okay, and so that means we need to set the negative 16x squared plus 79x plus 5 equal to 0. That's the ground when y is 0. And so to solve by factoring, you do not want a to be negative. And so you can think of it as dividing everything by -1. The right side would still be 0, and then everybody's sign would change. Okay, and so now a is at 1, and so a times c is negative 80. We need two numbers that multiply to negative 80, but add to this negative 79. Okay, and so that would be 80 or negative 80 and positive 1. And so when I split the middle term into those two numbers, we can factor by grouping. Okay, and so this first set can be divided by 16 and an x, which leaves me with an x minus 5. The second pair doesn't have anything but a 1. The x minus 5 matches, that is one of my factors, and the other comes from the 16x plus 1. Okay, remember this all equals 0, and so either x minus 5 equals 0 or 16x plus 1 equals 0. In this case, x equals 5. In this case, 16x equals -1, so x equals -1/16. And so when we look at our answers, the negative solution is not going to make sense, okay? And so looking at our graph, that's back in time. Negative time doesn't make sense. Negative time does not make sense. It's not reasonable. And so you would answer the question with 5 seconds. After 5 seconds, this javelin will hit the ground.